Welcome to EPG Pathshala lecture series on data analytics. In this session, we will continue discussing about the final part of MongoDB portions. As part of this session, we will understand various important components essential for satisfying the CAP requirements. As part of it, we will first start with the process of replication, how it is done in MongoDB, followed by what is the need for horizontal scaling and how it is done using sharding in MongoDB, and finally, we will learn how connectivity to other application development frameworks may be done from MongoDB environment. Replication. Now, why do you require replication? What is replication? First, let us discuss what is replication. Replication is the process of synchronizing data across multiple servers. Now, why we talk about multiple services? When we are going for a distributed environment, you may have the data in multiple servers, and when you are querying, queries may be concentrated on specific servers. Sometimes the query may be ad hoc and you may not know where the query may come into picture. In such scenarios, you compulsorily need to have the data replicated in some optimized locations. Only then queries can be answered very quickly and effectively. So, you need to synchronize data across multiple servers. Replication actually provides some form of redundancy, but the advantage of replication is it increases the availability of data by means of making multiple copies of data on different database servers. Replication protects a database from the loss of a single server, meaning in case if one server is down or say is crashed, then the data in that server may not be lost forever, because you have the data replicated and made available in another server. Therefore, replication in one way helps in avoiding data loss. Replication allows us to recover the data from hardware failure and from service interruptions, and by having additional copies of the data, we can dedicate one to disaster recovery, reporting or backup. Thereby, replication helps in various ways, and it helps in making the data available for the application at any point of time. So, this is related to availability of the CAP property. Now, let us understand how replication is happening in MongoDB. Replica set in a MongoDB is actually a group of 2 or more nodes. Generally, in MongoDB environment, it is minimum 3 nodes, that is minimum 3 node is required. As shown in this diagram, you will find say a primary node and you will be having 2 secondary nodes. These 2 secondary nodes are the actual replicas of the primary node. So, whenever the application, that is the client application, is connected to this primary, and at some point of time when the primary fails, then what may happen is immediately the application will be switched to the secondary. Once the primary is back here in the sense recovered, then the application still is connected to the secondary, but now the primary will be along with the secondary for the purpose of holding the data for duplication. So, at any point of time the data is made available and you have minimum of 2 secondary nodes which are replicas of the original data. So, at time of failures, maybe automatic failure or it may be due to a downtime because of maintenance, the election actually establishes for primary and a new primary node is selected. So, after recovery of the failure node, it again joins the replica set and works as a secondary node. So, this way these replica units will keep going and the client application will not be down at any point of time. Replication actually needs conversion of the standalone MongoDB instance to a replica set. Suppose you want to convert a replica set, the following steps need to be followed. There are 2 phases. The first phase is shut down already running MongoDB servers. The second step is start MongoDB server by specifying the replica set option. So, the general syntax for doing this replication is MongoD, the name of the port, then the database path and the replica set instance name. If these parameters are provided, then replication can be done. For example, you have a query MongoD port number 27017, the database path is this path and the name of the replica set instance is RS0. Now, what it will do is it will invoke that is it will start a MongoD instance with the name RS0 on the port 2701. Then you will have to start the command prompt and connect to this MongoD instance RS0. In Mongo client, we will have to issue the command rs dot initiate, that is replica set dot initiate. This command is issued for initiating a new replica set. Then when you want to check the configuration of the replica set, you can issue the command rs.config. To check the status of the replica set, we can make use of the command called rs.status. So, with these set of commands, we will be in a position to create a new MongoDB instance of replica set, use it for replicating. You can initiate, you can take a look at the configuration of the newly setted replica instance, and then also you can know the status of the given replica instance. This is how replication happens in a MongoDB environment. The next important concept is sharding. Sharding is a very important method with which you try to make the data available similar to the replica set. What is happening so? Sharding actually relates to partitioning and then making the data available. So, here in MongoDB environment, sharding is a method for storing data across multiple machines. MongoDB uses sharding to support deployments with very large data sets and high throughput operations. Suppose you have a very large data and this data need to be processed simultaneously, then you can shard the given data into small chunks and then make it available in different machines. So, whenever a query gets executed, the query itself can be run parallelly by means of defining subqueries and then running those subqueries in the respective shards or the chunks. This is how sharding helps a lot in partitioning. Now, what is the purpose behind sharding? Sharding normally will be very useful whenever there is a high query rate. Because of very high queries, what may happen is the CPU capacity may be exhausted, the CPU capacity of the server may be exhausted. In such scenarios, what may happen is few of the queries will have to wait until some CPU gets free. In some other scenarios, you may have a very large data set which exceeds the storage capacity of the machine or the server. In such scenarios, I cannot have the entire data set for my analysis. Now, you may be having a working set whose size is very large than the system's RAM or with respect to the input out capacity of the machine, the place where you are trying to do the analysis or store the data. Or sometimes you will have to address the issues of scalability. Database systems have two basic approaches, that is to address the issues of scalability. Database has two basic approaches, one is vertical scaling, another one is sharding. Now, whenever you find these scenarios or whenever you forecast such scenarios may be part of your environment, then sharding makes all these challenges go away by means of making the data available in multiple partitions. So, when you want to scale, as I mentioned, you can do it in two ways. One is the vertical scaling, another one is sharding. Now, let us understand what is vertical scaling. Vertical scaling is basically adding more and more CPUs and storage resources to the existing environment to increase the capacity. Now, when you add more and more CPU and more storage, what you are trying to do is you are trying to accommodate more and more data and then process them by more number of CPUs. But this has certain limitation. The first limitation is in terms of performance. We may think that by adding more number of CPUs, the performance may be improved, but it has been proven that the performance will be increased only to certain extent by means of adding more CPUs. After that, there is a limitation on the address bus capability, and hence the performance will not increase or it will become saturated. So, because of the large number of CPUs, we should not think that the performance may increase. It is not so. The large amount of RAMs are disproportionately more expensive than smaller system. This is also another limitation. Additionally, what happens is cloud based providers may only allow users to provision smaller instances. Otherwise, the practical maximum capability of vertical scaling is limited. Because of these limitations, in many environments we may not go for vertical scaling, and vertical scaling may not help in improvement of performance. So, what is it we need to do? We need to go for horizontal scaling. So, horizontal scaling is also known as sharding. Now, let us take an in-depth look into sharding. Sharding, how it can be defined is, it is a process of storing data records across multiple machines, and it is MongoDB's approach to meet the demand of growing data. So, what exactly we are trying to do is, we are trying to process storing data records into multiple machines. When you want to store data records into multiple machines, you are not storing all the records. Instead, you take a voluminous data, you divide it into partitions, and the partitions are going to be stored into multiple machines. So, as the size of the data increases, single machine cannot handle or may not have sufficient storage space for accommodating the entire data, nor it may provide an acceptable read and write throughput. At this point of time, sharding will come to help. So, sharding basically divides the data sets, as I already mentioned, and distributes the data over multiple servers, are called as shards in MongoDB environment. Each shard thereafterwards acts as an independent database, and collectively the shards make up a single logical database. This is actually a great advantage in MongoDB environment. Sharding, because of this, solves problem with horizontal scaling. With sharding, you can add more and more machines, which is just going to support the data growth and the demands related to reading and writing data from secondary storage environments. So, what are the advantage of having sharding? Sharding actually addresses the challenge of scaling to support high throughput and large data sets in terms of performance and in terms of accessing data. So, what exactly it does? Sharding reduces the number of operations each shard going to handle, because since I have partitioned the data, only certain amount of data is available in a shard. So, when I execute a query, only part of the query is going to be executed on the shard rather than the entire query, and hence accessing shards is going to be very limited. Each shard processes only fewer operations as the cluster grows. As a result, a cluster can increase capacity and throughput horizontally. This, for example, is to insert data, the application only needs to access the shard responsible for the record rather than accessing an entire database. In many regular traditional database environments, when you want to access a specific set of records or record, you need to access the entire table, but in case of sharding, you just need to know where exactly the record or set of record is available, and only that particular shard is what you are trying to access. The advantage, that is the second advantage of having shard, is it reduces the amount of data that each server needs to store and process. So, each shard actually stores less data as a cluster grows. For example, if a database is going to contain 1 terabyte of data set, and assume you are going to have 4 shards. Now, what is that you can do is you can divide this 1 terabyte of data into 4 chunks of each size 256 GB of data. Now, these 256 GB of data can be stored into the respective shards named A, B and C, A, B, C and D respectively as shown in this diagram. So, what happens is now this one single collection has now been divided into 4 partitions and placed in 4 different shards. Now, each and every shard can act independently. So, here in case if there are 40 shards, then each shard is going to be divided and only 25 GB of data is going to be saved in each and every shard. Now, what happens? The quantum of data which is going to be saved into the shard is less. Therefore, accessibility to these shards are going to be very limited and accordingly the performance may increase because of this. Now, what is the need for shard? This is another important thing you should know. Whenever you do replication, all writes go to the master node. Therefore, the master node will take care of where the write need to be performed, and when you are executing the write, it will be executed on a specific shard. So, the latency that is associated to executing queries will only go to the master or will only be associated to the master, not with respect to the shards. Simple replica set has a limitation of 12 nodes. Memory associated to these nodes cannot be very large, but the active data set sometimes may be very big. Sometimes the local disk may not be so big enough to hold the entire data set, or in certain scenarios vertical scaling though possible, but it proves to be expensive. So, what happens in such scenario is ultimately you will have to go for sharding only. So, if you are going for a scenario where only the master is going to make use of the replication, or the latency associated to sensitive queries are associated to master only, in such scenarios sharding will come to help. So, these are the situations where you can understand the need for shard and accordingly you can make use of sharding. Having understood what is sharding, what are shards, why do you require sharding, now let us take a look at the various components of shard. As shown in this diagram, you can find 3 important things. One is the query router, the second one is config server and the third one is the shard itself. Now, let us understand each and everything in detail. Let us take the first component, query router. The query router is actually a Mongo instance, basically it is a Mongo instance. This Mongo instance interface between the client application and the direct operations to the appropriate shard. So, you have the client applications here, the clients will say what type of operation need to be performed on the data. It is this query router which will act as an interface between the client and the shard and it will execute the respective operations on the respective shards. The query router actually processes and targets the operation to the shard and then returns the results to the query. So, these are the 2 important and fundamental operations of query router. So, it acts as an interface and it performs the respective operation and returns the results to the client. The second important component is the config server. Config server actually stores, it is clusters metadata, not clusters of metadata, it is the clusters metadata. So, this data contains mapping between the clusters data set to the shard. The query router makes use of this metadata for the purpose of targeting operations on specific shards. In actual production environment, shard clusters have maximum of 3 config servers only. So, this config server is actually a metadata which is used by the query router to perform operations on respective shards. The third and very important component is the shard. Shards are the actual partitions which store the data. They provide high availability of the data and also data consistency. In a production environment, each shard is a separate replica set. So, now when you take a look at this as a big picture, you can find the query router, the config server and the shard put together helps in the data availability and making the data consistent, which are two important requirements of the CAP requirement. Now, let us understand about the data partitioning, how that is done in MongoDB using the shard. So, MongoDB actually distributes the data or the shards at the collection level. Now, the sharding actually partitions a collection's data by the shard key. Now, when I talk about shard key, every shard must be identified by means of a specific key, which is called as the shard key. So, this shard key is either indexed, which can be an indexed file, or it can be an indexed compound field. So, either it can be a single index field or it can be a compound index field that exists in every document in the document collection. MongoDB what actually does is, it divides these shard keys into chunks and then distributes the chunks evenly across the shards. Why this happens is, only then unique shard keys can be assigned to the divided chunks. So, to divide the shard key values into chunk, MongoDB uses either a range based partitioning or a hash based partitioning. If it is a range based partitioning, how it looks like this as shown in this diagram. So, the entire key space is taken and it is divided into ranges. Say here in the given example, there are 4 chunks, 4 shards are going to be created. So, for this 4 shards, the entire key space is divided into 4 and say from minimum key to say some 75% of the key value is given to the first chunk. Then 0.75 to 0.25 range of value is given to chunk 2. Likewise, each and every key space is assigned to the chunk. So, in other words, a range of key value is assigned to different chunk. This is called as range based sharding. The next one is hash based sharding. In hash based sharding, each and every key is given to a hash function, which in turn will assign the key to a specific chunk. So, here you have 4 chunks, you have various key values, the key values are given to the hash function and accordingly each and every chunk will receive specific key values. So, in MongoDB environment, shard keys are actually created and distributed either using range based partitioning or hash based partitioning. Now, having created sets of replicas and having created partitions of data, next important thing in MongoDB is creating a backup and deploying it. We can make use of commands like MongoDB to create a backup of the database. You can make use of MongoStore, which is a command which restores all of the data from the backup directory. Whenever you want to check the status of all running MongoDB instances and return the counters of database operations, then you can make use of MongoStat method. So, the MongoStat method will include inserts, queries, updates, deletes, cursors, etc. All these counters of database operations will be returned as a statistics. You can make use of MongoTop to track and report the read and write activities of MongoDB instances on a collection basis. By default, MongoTop returns information every second, which you can change it automatically. But if you mention as MongoDB-III, then it is going to return values for every 30 seconds. Now, we should also know how MongoDB can be connected to various other application development frameworks. Before you start making use of MongoDB with Java programs, you need to make sure that you have MongoDB database connectivity, MongoDB JDBC driver and Java setup on the machine. So, to set up MongoDB JDBC driver, you first should have downloaded the jar file from the path download mongo.jar. Then you see to that you have the latest release of it, and then you can include this mongo.jar to your class path. For example, here this slide you can find a code snippet which is used for connecting to the database. Here you can find various imports related to database connectivity like DB, DB collection, basic DB objects, DB object, DB cursor are all various database related imports required for connectivity with Java program. Here the first thing you should do is you should connect to the server using the new Mongo client connect command. Then you need to connect to your databases using the getDB method, and then you should verify whether the connect to the database has been done successfully and then authenticate it. If you have done these steps, then you are properly connected to the database. How to connect MongoDB in PHP? For this also you require proper file execution files. Having downloaded the proper file, next what is that you should do is you should set the path as phpmongo.dll, which need to be unzipped, and you will have to set this by default. Having done this, a simple fragment of code which says how MongoDB may be connected to PHP. So, the new Mongo client will help you connect to the MongoDB database, and then you need to select which database you want to make use of. There are various other concepts in MongoDB like relations, atomic operations, advanced indexings, map reduce, regular expressions, text search, etc., but these are all not going to be part of this particular session. So, we have finally understood what is MongoDB, where it is essential, what are the fundamental querying options available in MongoDB, and how it is useful for making the data available as well as available to all applications. So, to summarize, replication helps to recover from hardware failure and service interruptions. Sharding supports data growth and the demands for read and write operations. Replication and sharding together are necessary for availability of partition in CAP and availability in CAP. Thank you.